All right, guys, so this is section 7.2, talking about trigonometry today. Specifically, we are going to go over ratios and right triangles. All right, so you've seen this before, ratios and right triangles. And when we talk about these, we have to be careful with which angle we're using. We're going to use the Greek letter theta. All right, looks like this to help us out. And that just tells us which angle we're working with. So here would be angle A. And when we do that, we have we have a couple different parts to this. We have, compared to this angle, the opposite side, which would be this one. We have the adjacent side. That's the side that's next to it. And then, of course, the hypotenuse, which is this side over here. Now, I'm going to pause it really quick. And let's say instead of angle A, my theta was in B. All right, so after pausing that, you can see I wrote a red theta in right here in angle B. And now my opposite side, adjacent side are switched because opposite of B is this side down here. The closest side, the adjacent side is over here. The hypotenuse, of course, still stays the same. The hypotenuse is always going to be across from our right angle. All right, those are important because we have sine, cosine, and tangent that depend on which angle we're using. And we have the word SOHCAHTOA to help us out, where if we have sine, we're going to use the S, the first three letters, which are going to give us the opposite side over the hypotenuse, opposite over hypotenuse. Cosine, the CA part of SOHCAHTOA, uses the C, and again, in this order, we have A over H, adjacent over hypotenuse, and then lastly, TOA, the T stands for tangent. Tangent's going to be the opposite side over the adjacent side. The order is very important. That's going to be top over the bottom, or numerator over denominator when you write these out. All right, if I scroll down a little bit on this page, you can see that we have, let me extend this. You can see we have three other trig functions. We have cosecant, secant, and cotangent. All right, and they're written in this order because cosecant kind of goes hand in hand with sine. Secant sort of goes with cosine, and cotangent, of course, goes with tangent. All right, so if I switch colors, the way that I learned this is 1 over sine for cosecant. Secant is 1 over cosine, and cotangent is 1 over tangent. All right, now I want to work out a little bit of math here, because if we think of 1 over sine, and sine is opposite over hypotenuse, this would be 1 over opposite over hypotenuse. And if we flip and multiply this, since this is a fraction that's being divided by a fraction, if I think of 1, for example, as 1 over 1, then here's my big fraction bar. So I'm going to multiply this by its reciprocal, 1 over 1 times, flip and multiply, hypotenuse over opposite. 1 times h is h, 1 times o is o. So now cosecant actually equals h over o, which is the exact opposite of what we had up here. So if I erase some of this, maybe I'll use red to say that instead of sine being opposite over hypotenuse, cosecant actually equals hypotenuse over opposite. They just flip. All right, they just flip. And so does the other two. So we don't have to work out the math here. We can just say that secant is going to be hypotenuse over adjacent, and cotangent equals adjacent over opposite, just the opposites of these. All right, so if that's true, this next example says if secant of theta equals 6 over 5, then find cosecant. Well, we know we have to flip it, or not cosecant, I'm sorry, find cosine. So we have to flip it, though, because secant and cosine go hand in hand. So instead of 6 over 5, cosine would equal 5 over 6. Similarly, if sine of theta equals 0.8, then cosecant of theta, we need to find that. So real quick, 8/10. If I write that out how it sounds, 8/10. If I simplify this, that becomes 4/5. right? 4/5. So opposite of 4/5 is going to be 5/4, which is what cosecant will be, 5/4. It just flips. Okay, coming down here to this next example, we need to first use the Pythagorean theorem to find f. So I'm going to pause it and find that really quick. All right, so I just used the Pythagorean theorem, a squared plus b squared equals c squared to find f. And I got 3 squared plus 7 squared equals f squared, 9 plus 49, which is 58. Take the square root of both sides, and we get f equals the square root of 58. Okay, so I'm going to use that to find sine, cosine, and tangent. So sine, remember we're doing sine of e here, so my theta, if you will be an angle e. Sine is going to be opposite over hypotenuse, which is 3 over the square root of 58. And remember, we have to rationalize the denominator, so I'm going to multiply both by the square root of 58 over itself. The reason I can do this is because anything over itself equals 1, and when we multiply times 1, it does not change it, but it makes it look different and makes it look how we want it. So we're going to have 3 square roots of 58 over 58. Square root of 58 times square root of 58 is just 58, like that. Same thing for the cosine of e. Cosine is going to be adjacent over hypotenuse. So that's 7 over the square root of 58. Again, multiply times the square root of 58 over itself, rationalizing our denominator. And it gives us 7 square roots of 58 over 58. I would simplify this if I could, but I cannot simplify anything there. Lastly, tangent of e is going to be opposite over adjacent, which is just 3 over 7. All right, now I want to look at these first parts that I wrote. 3 over the square root of 58, 7 over the square root of 58, and then 3 over 7. Because when it comes to cosecant, secant, and cotangent, I can just flip those. All right, if I flip the first one, it's going to be the square root of 58 over 3. The next one, we're going to have the square root of 58 over 7. And lastly, cotangent of e is just 7 over 3. The reason I wanted to do that from the beginning, from my first ones, is because here when I flip it now, the square root will be in the numerator, and I don't have to rationalize any denominators. They're all just whole numbers here, here, and here. Okay, so those would be our trig ratios. All right, I want to do it again. This time, find the 6 trig ratios for angle A. Angle A, I'm just going to put my theta up here in angle A. And again, I'm going to pause it and find this side down here. I'm going to call this little a. And I'll use the Pythagorean theorem to find that. So I'll pause it. You guys may pause too and find it on your own. I want to bring you guys back in real quick in this step right here. So I got the a by itself. Remember, we had a squared plus b squared equals c squared. I filled in my different parts, and I was looking to find the a. So it's still just a squared. I want a. Now, when I take the square root of both sides on this one, that does give me a on this side. But over here, I think this can simplify a little bit. In fact, this actually equals the square root of 9 times, that's a 9, times the square root of 55. Now, the reason I chose 9 is because 1, it goes into it, so you have to use that. But 2 is that the square root of 9 is 3. Okay, so this gives me a equals 3 square roots of 55, which should be able to simplify a little bit more with this 3 out front than if I were just to leave it as a square root of 495. Okay, so now we have a equals 3 square roots of 55. Write that in here, 3 square roots of 55. We're going to find the 6 trig ratios for angle A. First off, we're doing sine of A. Sine of A, and this is capital A now, so we're using this angle. That's why I put the theta up there. Sine of A is going to be opposite, which is our 3 square roots of 55 over the hypotenuse, 24. Okay, and again, you can see we took out this 3, and that's going to be important because 3 and 24, the outside numbers, outside the square root, are both divisible by 3. And so if I divide both by 3, I'm just going to end up with the square root of 55 over 24 divided by 3 is 8. So this sine of A is going to be square root of 55 over 8. The square root's on top. so we do not need to rationalize anything there. All right, what about cosine of A? Cosine of A, we're going to use 9, our adjacent side, 9 over 24. And again, these are both divisible by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. So it simplifies to be 3/8. Tangent of A. Tangent is opposite over adjacent. 3 square roots of 55 over the adjacent 9. 3 and 9 simplify to give me the square root of 55 over 3. All right, and then cosecant of A, I can just flip my answer, and we get 8 over the square root of 55. I do have to rationalize this one, multiply both sides by, or both the top and the bottom by the square root of 55 over itself. And that gives me 8 square roots of 55 over 55. What about secant of A? Secant of A just flips to be 8 over 3. Take the most simplest form there. And then lastly, cotangent of A is going to be 3 over the square root of 55, which again, I have to rationalize the denominator. Multiply both sides, or both the top and the bottom by the square root of 55 over the square root of 55. That gives us 3 square roots of 55 over 55. All right, and those are the 6 trig ratios for this one. All right, this next question, we have to fill these in a little bit, and they try to be tricky with it, but I think we can get it. It says if sine of B equals 1/2, so let's just start there. Sine of B, so here's my theta. Sine of B is 1/2. Now, sine, remember, is opposite over hypotenuse. So opposite would be 1, and my hypotenuse would be 2. Okay, and then cosine of B is square root of 3. I should go over this. Square root of 3 over 2. So let's see. Cosine is adjacent over hypotenuse. Again, this is going to work out. We're going to have the adjacent side be square root of 3 over the 2, which I already have. And so I already have my 3 sides. Then it says find the 4 remaining trig functions. So we already had sine of B, which is 1/2. And we also have cosine of B, square root of 3 over 2. They gave us those 2 from up here. Let's find the other ones. Tangent of B. B is going to be 1 over the square root of 3. But we have to rationalize that. Multiply by the square root of 3 over itself, giving us the square root of 3 over 3. Okay, and then secant, or cosecant of B, excuse me, up here is just going to be 2 over 1, which is 2. Go ahead and simplify that. And then secant of B is 2 over the square root of 3. Rationalize that denominator. 2 square roots of 3 over 3. That's a 3. It's a bad 3. And lastly, cotangent of B. Remember, I'm just flipping these to get these 3 over here. I'm flipping the ones across from them. So this is going to give me 3 over the square root of 3, which is multiply square root of 3 over itself. So we have 3 square roots of 3 over 3, which the 3's cancel, giving us just the square root of 3. Now, on this last one, I want you to see that if I would have started with this, where I ended up, and just flip that, that would have given me the square root of 3 over 1, which is exactly what I ended up with. Square root of 3. All right, and there you have it. Those are our notes for today. Make sure you get these all written down. If you have to go back and copy anything, if I was going too fast or too slow, make sure you get it all written down. Thank you.